to have this kind of material on YouTube. So now I press record, and just for those who started to watch the YouTube link, we just found together some toolboxes not developed by MathWorks that can be useful. Another thing that I wanted to talk about today is this, well, the file system. We kind of looked at it yesterday when we mentioned about the IDE, Integrated Development Environment. But another thing that you kind of already came across yesterday are these Matlab operators. So Matlab is actually a nice web page that are so-called operators and special character. I can paste it to the chat or actually to the HackMD so that it stays also in the future. So on this web page, there's all the list of operators. Yesterday we came across, for example, to the operators that you know, that they do what they are expected to do, like the plus sign, minus, multiplication. But then there's some, this dot product, this element-wise multiplication, they're not, how can I say, they might be different in other languages, in other programming languages. Then yesterday we also tested quickly this power, so exponential. But even there is something called dot power, so element-wise exponential. Kind of, if one just look at the simple math operators, you can already see that some have the dot and some don't have the dot. And the idea is basically that if there is the dot, it's going to work kind of element-wise. So that if I do a vector, so dot x to choose the square of each element. Instead, if I do a square, here is throwing an error because in a matrix algebra, you were kind of you need to have a the idea is that with the dot, the operations are element-wise, each element, and without the dot, they are so-called algebra, so they are used matrices. Most likely, you don't deal with matrix algebra in your work, and most likely you, like at least myself, I find more useful and more often using these dot operators rather than the matrix operators. But of course, you might be doing matrix things, and so you need to rely on the other operators. And then there are other types of operators that we will see today when we talk about basically checking the validity of statement, like if something is true or false, needs to be done. These are kind of equal if two things are identical, and other operators. In general, I find, even though I've been using Matlab for many, many years, I still find it useful to kind of have a page that reminds me of all the types of operators, because the same operator might have different things, different meanings in different contexts. So it's good to go back again. There's some operator I don't even remember myself, but it's a good boxes and the operators. Now, if there's no questions, and as a reminder, you can ask questions in the basically here, like I added this link to the operators. You can type your questions or comments. We try to go through them once in a while to check if there's any comment. And now we can basically recap what we today. Just to remind you, we are online course or online lecture, so-called the software carpentry lecture on the kind of basics of MATLAB, programming with MATLAB. It's a basic course on the introduction of all these elements of the MATLAB language. So yesterday we did the setup where we downloaded the requested files and we checked the kind of, the basics of working with variables and then the basics of arrays. I can paste the link on the Zoom chat for your convenience if you didn't find it. And what else? Yes, so then we reached the part 3 where we were mentioning that it's important to kind of plot the data and visualize the data you have. If you missed yesterday, maybe what you need to do is to check the setup where we download the files that we are going to use. So now we maybe quickly go again through the section 3 because we didn't finish it, and then continue. Most likely we are able to cover up to the part 6. Then next week on Tuesday, we are able to finish this course, this software carpentry course. And I was thinking of reserving the last section, so the last session, which means Thursday, for kind of your requests, for kind of, if you wanted to know a little bit more about the topic that is not covered in this software carpentry material. I remind you in the HackMD, if you scroll up, that in the icebreaker from yesterday, you wrote down your learning goals, so what you kind of expect to get from this course. And here you can still, update your learning goals if you want to add something that you wish, to learn. I understand that, of course, 12 hours is very short time to learn something too advanced, but if there's many of you, for example, I don't know, I just picked this one, that would like to know visualization of 2D and 3D data, maybe we can spend the last session showing a little bit of, how to get started, at least with those type of problems. And all right, so now let's check plotting data. I'm gonna do like yesterday, where I'm gonna have half of the screen used for the course material and the other half for the MATLAB prompt. The idea being that you are now able to basically use also half of the screen, whether you wanna cover the teaching material or the prompt that I'm using myself, so there's more space for your screen, for at least those who have only a single screen. So yesterday we were using a variable called patient data. I like to start clean, but maybe you still have the things from yesterday, but I'm just going to do a clear all and close all and CLC, which also clears what we see here above. Kind of a fresh start with the MATLAB command window. And then we were loading this patient data. I'm just going to start typing the beginning of the word that we did yesterday, and then I'm going to use the arrow up key, because then MATLAB is going to go through the history. And yes, so this was how I loaded yesterday the patient data for at least this, from this CSV 01. Yesterday, some of you who have a newer version of MATLAB, they were able to use the read matrix as in the teaching material, but also load in this case. It's good enough. All right, so now I can check the workspace with WOOS. And yes, we have this patient data from 01, so the first batch of patient data. And if I remember correctly, these were 60 patients and 40 days where they were measured. All right, so if we go straight to the plotting and skip, we don't need to go back through this, how this mean and maximum. And basically, so a plot that we did yesterday was the so-called heat map. So I'm gonna type it, and you are highly recommended to do the same. One comment from yesterday is that I could try to go a little bit slower when I code, so that you have enough time to code with me. So this command, I'm going to press enter now, is going to basically show a so-called heat map of the data, like we see in the teaching material. Yesterday, though, in the teaching material, they didn't have a color bar. I like to always have a color bar. So I also type the command color bar and press enter, and this adds a color bar to the image. So now we have our 60 rows, the web pages, and 40 columns that are the days. And this color bar is kind of something that tells us about the numbers that are stored in this matrix. So if something is very yellow bright, it has a value of 20. If something is really dark blue, it will have a value of 0. Of course, we should always label our axis. So here we also add a title. The title wants a string, so I'm using this apostrophe, inflammation. And then we want to label the x axis, day of trial, and the y axis, patient number. All right, so if I go back to the image, I see that now we have axes that are labeled and also kind of the main title of the figure. So then we also checked another Matlab function for plotting this, for doing plots. And the other function is the so-called line plot, which the name of the function is plot. So I'm now going to type the command figure, which just creates an empty figure. This is useful because then in my list of windows, I can go back to figure 1, which was the one with the heat map, and then I have another window called figure 2. So now we stay in figure 2. And in this case, we want to have a line plot of the mean of the variable patient data along the dimension 1. So first, along the dimension 1 would means that it will kind of follow the top to bottom, so that what we see is that we get rid of the 60 and we get 40 values of so-called daily averages. So yes, we have the plot, but of course we miss the labels. So now I'm going to be a little bit lazy and just copy and pasting. By the way, somebody was mentioning that with Matlab Online, it was not possible to paste multiple lines, and I had experienced the same error. So I don't know. I guess you just need to paste one by one. All right, so now the figure, yes, should have also the axis. So now we have 40 days of trial and this kind of average inflammation, because we computed the mean, which is the arithmetic average of along the columns. All right, then here in another plot, I'm going to close now all the windows, just to, it's not nice to have too many windows open. So close all, closes everything. Here they do another plot where instead of plotting the mean, they plot the maximum. And maximum, we had this, the dimension is kind of the third input of this max function. So the second input can stay empty. And I'm gonna be a bit lazy and copy them just because we did it yesterday already, and make sure that we get the same. Yes, we get the same as they have there. And same story here. I'm gonna now type figure, so I keep open the figure 1, and then we do this other plot using this time the minimum. So now figure 2 as the minimum and figure 1 at the maximum. So this is kind of where we left yesterday. So now we can do these small exercises. Hopefully you're all at the same pace. You are free to use these zoom buttons if I'm going too fast. We can quickly check if there's anything on the HackMD. There's no questions, so I guess we're doing all fine. So now the kind of exercise and task that we have is When we plot just one variable using the plot command, example plot y or plot the mean like we did here, what do the x value represent? So this is something that you can kind of see from the data here, that in this case it doesn't really start from 0, but it actually starts from 1. So basically, if we use the plot command like we did here, basically passing only a single variable to the plot command, then I click on the solution, and yes, the x values are the indices of the data. So just 1, 2, 3, 4, 5, etc. We can see it easily. For example, I'm going to close all and make a variable a that are all the integers from 1 to 10. And now if I do a plot of a, I will just see a line that starts that as in basically in the y-axis as the values of a, and in the x-axis as the integers, the indexes. If we would have done something that goes, if you remember yesterday, with jumps of 2 from 1 to 20. So now a has these values. And now if I would do plot of a, we get, that now on the y-axis, the values of a are jumping from 1 to 19. Instead, the indexes are staying the same from 1 to 10. So then in this small exercise, they're asking us, why are the vertical lines in our plot of the minimum inflammation not perfectly vertical? So if I check the image here, you would expect that, that this is like a step function or discrete function. But in practice, what Matlab does with the plot is just connecting the dots. So the one data point is here, where the integers are, and then there's a data point at index 4, and then there's a data point at index 5. And Matlab doesn't know what to plot there in between, because we don't have any data between the index 4 and index 5. So Matlab just will connect the dots. So in this sense, this will never be completely, straight line. And I guess if I highlight the solution, this is what we see. Yes, Matlab interpolates between the points on a 2D plot. Then the last exercise is create a plot showing the standard deviation of the inflammation data for each day across all patients. So we need to understand, so if the plot that we did here, I'm just not going to start typing plot and scroll up with my key up. So if, for example, for mean, for the minimum, was the kind of thing that we need to type. We need to check how is it for the standard deviation. And here specifically, we can check the help, online help of Matlab. And now it's telling us that if you use it as X, kind of if we have a vector, a row vector, then it's kind of, doing the operation along the first dimension. But if we want to specify the dimension, we scroll a little bit down, and then this is how we should do it. Specifically here, the Matlab help is saying that to do the standard deviation along a specific dimension, you need to pass another parameter, W, which has to be 0 to use the default normalization, or 1 to use N. So of course, our purpose here is not to do statistics. Maybe we are happy with the default parameter. So basically what we would need to write is, if I scroll down again, so if before we were writing this for the minimum across dimension 1, here we want to write standard deviation of patient data. 0 is the default parameter for this function, and the dimension is 1. And now let's see which figure, and here's the figure. We still miss the labels of the axis, so we still want to have an X label. It's the same as before, so I just start typing X label and then arrow up, and it's day of trial. And then the Y label, in this case, it's the standard deviation of inflammation. And then the title can be standard deviation inflammation per day. And deviation of inflammation per day. And now let's see the solution that they propose in the teaching material. And basically it's the same. I had different labels, but this is how we did it. So I give you a little bit of time if you wanna type it yourself and check things yourself. Oh yeah, sorry, those are the Zoom. When people come in and out, I can make it silent. 1 second. Okay, I made Zoom silent. There's no other questions, so we can continue now with our teaching material. So yeah, now it is often convenient to combine multiple plots into a single plot. I'm sure if you ever read a scientific paper, you might have seen that often within the same figure, there are sub-figure panels. So this is very convenient because even here, it wasn't that nice to have to jump between multiple windows. Okay, there's only one open right now, but it gets very useful to have multiple plots into the same window. So here, the command to do this with Matlab is subplot. So let's start fresh again. I close all the windows. And so when I type subplot 1, 2, 1, so I quickly explain what it is. This means that it's a subplot. So it's like multiple plots. And there will be one row the first location. So we are basically asking Matlab to prepare a figure that will have one row of plots and choose the location. Okay, so now it basically has one. And now in this one, split. And then of course we need to label our axis. So basically all the comments, all these plot comments that follow the subplot, these all will the subplot that we have specified. So now if I go, yes, so now this subplot 1 label for the X, for the Y, and now we do the same. You see that now the location 2 is empty. So once again, I can do subplot 1, 2, 2, and now we have selected the location 2, and then here we have the plot of the minimum this time with the labels Y label and the X label. And now, so if you see, so now we have within the single figure, we have a plot for the maximum and a plot for the minimum. And with these subplot commands, we were able to tell Matlab when to plot the maximum and when to plot the minimum. If we scroll down a bit, we see exactly the same in the teaching material. All right, so we're basically done with this section 3. Our work so far is basically, we were basically able to get some plots and some understanding of the data in this file number 1 that we have loaded. But if you remember, in the data folder, we actually have 12 of these files. So it starts to get a bit tedious if we manually need to load each of the remaining 11 files and then, repeat all these plots. So now basically the point of the next part is to kind of, how can I say, automate things, make things that are reusable. For example, making a plot that can automatically go through all the 12 files. So let's start a little bit with this section 4, and then I'm trying to gonna have a break at 12:50 like yesterday. There's no comments in the HackMD. So, well, basically here they were just saying what I just said, and I'm going to repeat a bit what I said yesterday, but it gets very useful. Rather than, so far we've been typing the commands on the Matlab command line, which is okay for this kind of interactive work. But tomorrow we might go to a different computer who doesn't have the history that we had, or we just switch to other work. It might be difficult to just go back to the history and see what we did yesterday or what we did a month ago. So the best way to kind of work with Matlab, and not just Matlab, with any programming language, is to basically write down the commands that you plan to running. So here they recommend us to basically create a file called plot_patient1. So if you type this will then ask you that plot_patient1 does not exist. Do you want to create it? I'm going to say yes, and now we'll launch the editor window. So now the command window is there in the background. You might have a different configuration in your Matlab desktop. You can also undock, kind of get out the editor from the within the Matlab window if you want to have multiple windows. But basically now we are in a script, in a so-called Matlab script. So this will be a file that contains Matlab instructions and is saved with .m, so that Matlab knows we could type in this file that we just started. Basically type commands that we will part 3. Specifically, we want to load the data, we want to create a figure and give all the labels. So now I'm gonna paste on the editor the same commands. The read matrix for me was not an option because I of Matlab. This is also you might have the same case as I have, that you don't have the most up-to-date version of Matlab. So for this CSV data, it's fine also to just use the load command, which is a generic command for loading data. And basically, yeah, now we have kind of, store all the commands that we want to run. So of course now I want to save this script, and I'm going to save with the save button. So now I can command window. I can type name of the script with ending M. So this will basically tell Matlab to run the script patient1. It's kind of execute all the commands that are written in patient1. So now I wrote the file name without a .m and press enter, and this will basically do what's written in the script. So it was loading the data, doing this average, plotting the average, and setting the labels. So then here there's a side note about the Matlab path. I mentioned briefly yesterday that kind of Matlab, or in it's not something specific to Matlab. We also have the same in operating systems, but basically the location where we are in our the so-called working directory is kind of reflecting the path. But of course, it is not just a working directory. There are other directories that are visible, in this case to Matlab. So the path where you are in the command window, you should kind of see it on top, or you can also type the command pwd that basically gives you all the list of subfolders up to where you are right now. But of course, there might be other subfolders where other things are stored. So for example, if I type which plot, Matlab tells me where is the plot function actually located. And it's in this, in my configuration, it's in these subfolders. So what basically means is that Matlab knows that there are other paths where Matlab should search for the functions that we're going to call or for the data that we want to load. So if you type the path here, you get a long list of folders that that basically Matlab is going to search through all these folders to find a function or a variable or a, well, not a variable, or a file name that is visible in the path. If you are searching for something that is not in the path, or if you want to type a function that is not in the path, basically Matlab will throw an error. So this kind of goes back to the toolboxes that I mentioned earlier, that sometimes when you have a toolbox that you have downloaded, you need to tell Matlab, there's a new toolbox. You might want to put it in the toolbox folder so that Matlab might see it for there, but sometimes often you don't have the rights, the so-called administrator rights to write in the toolbox folders. So then you can have the toolbox in a subfolder of where you are right now, and then you can add the path to that subfolder. So here, for example, this useful command, add path. So, you can basically with add path, Matlab, search also to this folder. So after this little parenthesis on the path, now it's 12:48. Maybe now it's good time for the short break. We do like yesterday, that in this 10 minutes break, those who want 1 credit, they can send me a direct message on chat with their name so that I know that you are in the room. Yeah, I save it and I will mark your presence. So here you can send me your name for the credit. And those who don't need the credit, you can stretch your legs for 10 minutes. In the meantime, I check the HackMD. Yeah, so All right, it's 13 o'clock. Yeah, we were just writing in the HackMD that I had the same connection as yesterday, which was working really fine, and today there's maybe something out of my control, but if it cuts, I'll try not to speak too fast. Also, yesterday someone was pointing out that sometimes I'm also going a bit too fast, so that hopefully the flow of the lecture is not lost. So yeah, basically we are here right now. So we wrote down a script that was doing something. If you lost the editor window, in my case, I can see it here. But of course, what is nice about scripts is that, you know, they do something in a way that we don't need to interact with them. And specifically here, our task, or what we're gonna add to this script, is the fact that the script will also save a PNG, in this case, an image of the plot, so that it's useful, you know, that next time we can go again through this image. You will find that it's very common that kind of the script wouldn't need to, how can I say, they wouldn't even need to be supervised, that you just submit the script will then run, will do what needs to be done, and then closes. And then maybe, you know, imagine that your script is very long and it needs to run for many hours. At the end, it can print, in this case, an image, which is the main output of the script. And then tomorrow or whenever you are ready to check the results, you can then, you know, open the files, open the output. So one thing for those who were not around yesterday, we also created a folder called results, because it's good to keep the data and the output, kind of the input and the output subfolders separated. All right, so I'm gonna add this extra bits to this script. Here, got the data, set the labels, and also what it basically does here is that it will store the output in the subfolder results, and it will be called average with the extension PNG. So I save the script. I go back to the command. The name of the script is plot patient 1. I press enter. And now if I go to the results folder, I see that there now I have an image called average.png that you can then open with whatever program you wanna check the images. So it's kind of a screenshot or a, you know, export of this figure. There is another box here that we already kind of covered yesterday, and it's about the importance of using comments in your Matlab scripts. What I like is that actually I like to first write down all the comments and then the actual code. There are special comments in Matlab, and specifically the very first one, as they say here, is a comment that can be used for the help, so that if somebody else will find your script, they can just type, like it says here, help, name of the script, and they can get kind of a small summary of the script. So if I go back to the editor, on the very first line, I can write something like it says there. I'm gonna type it, plot underscore patient 1. Then I save it, and then I can go back to the command line, and now I can type help plot patient 1. And now we have this, so that we kind of created the help for this script. It's the same like when we do help, let's say, of the function plot. You know, function plot, of course, has a longer help, but you know, we just kind of made a little help for the help output, help text for our script. All right, so now our next task is to modify the plot patient 1 script so that it creates and saves subplots rather than individual plots. And of course, we want to save the output in the results directory, subdirectory. So here again, this script is a little bit longer, and basically the beginning stays the same, but now we are going to use the subplot command. And the subplot command is called 3 times. So we're going to have 1 row of subplot and 3 columns of subplot. And then this would be location 1, subplot 2, and subplot 3. And then at the end, we save the subplot as a PNG. So let's all do it together and try to run it. You can watch me doing it for a bit, and it's okay to copy paste if you want to copy paste, but I'll try to be a bit slow so that you have enough time to do it. Okay. And then here we want to have the maximum and the minimum. And then we need the title. Oops. And then we need the X label, which is the same, and the Y label, which is also the same here, inflammation. All right, so now our new script has changed a little bit from before. I'm gonna save it. I'm gonna go back to the command line, and it's good sometimes. So you might still have those figures open from the previous rounds. So now you see. So I would like to type the command close all, which closes all the figures that are open. All right, so now we're ready to run our script, but let me check that I also changed the final line. Yeah. For the output, inflammation -01, and it will be a PNG, yes. So I save again, go back to the command line and type the name of the file, plot patient 1. And there's an error because I didn't copy paste. It's nice, actually, good teaching example. So I did a typo, and Matlab even tells me where's the typo. So I can just click in this line 13, and it points exactly where it is. And yes, I forgot the B of subplot. Now I can save, I can run it again, and yes, so now it created the 3 subplots, and in the results folder, we should have a new inflammation -01 PNG. All right. So when saving plots to disk, it's sometimes useful to turn off their visibility. This is maybe something that at the beginning it's not that useful, but imagine that you have to do hundreds or thousands of these plots that, you know, you might want to do something else if you're using your laptop and don't want to that like that kind of MATLAB runs in the background. Or sometimes if you will keep on using MATLAB for more advanced things, you might run MATLAB non-interactively in a so-called HPC cluster. So like at Aalto, we have Triton cluster, so that you don't actually have a display for for your MATLAB session. So basically, the only difference, we don't need to test it right now, but the only difference is that when we create a figure, we specify that the visibility is off. What it means is that the plots are there, they are in the memory, but they are not visible in the MATLAB, like in your laptop or whatever computer you are. And then also it's good at the end to basically close. This is the same when I type close all, specifically here it just closes the last figure that was open. And basically here they're just saying what I said. All right, so now we are done also with this part of the lecture. So the next part is 40 minutes, which should be enough exactly until the next break. So now we kind of, there's one raised hand, so you can unmute yourself, but remember that we are recording.
Yeah, I'm just wondering, you say these now go to record, to hard disk, and
yeah,
and you don't, you can also have them in such a way that they don't show. So are those plots now somewhere, so that, for example, let's say I'm writing an article and I want to include a figure there. Are these now, the plot you just made, is it somewhere so that, let's say outside MATLAB, you can access it?
Yeah, maybe.
Hello, you disappeared.
So
sorry, you have some network problem. We can't hear you. Okay, now I can hear.
Basically, when I was showing the ls command, we were checking this, the present existence of the files in the MATLAB command line. But of course, I can go to the folder where the images are. And yes, as you said, now we have actually a PNG image that I can include in the paper, or we can export other.
Okay, and where did the file name come from? Inflammation01.
Yeah, so this, we go back to the editor, and this is the file name. So it's the name of the subfolder, and then the name of the file. And the extension will be, basically this is a specific, in the help of the print function, there are different types of extensions that we can use.
Okay, so do I understand correctly? With this command figure, you tell that you're now making a figure. Then with subplot, you make this left figure. So the second subplot, you make the middle figure. Third subplot, you make the third figure. And then this command print gives where you write the figure you just made.
To disk, exactly. Yeah, exactly.
Okay, kind of complicated. Yeah, thanks.
Yeah, well,
I think I got it.
It's basically all the steps that you just described. That first we do reaction plots, and then we store them to disk.
Yeah, and this also shows you in MATLAB what you did, so it opens a window. So if I want to avoid that, I add to this figure these attributes, visible, or how was it?
Yeah, visible off, exactly.
Visible off. Okay, I think I got it. And how can you change it? This makes PNG. Can you make JPEG or something? Is it in this print?
Check
this DPNG. Can you have some other formats as well?
So if you check the help for the print function, here basically you will see that different types of formats, PNG, this is the EPS. And yeah, so then you can pick the one that you prefer. Here, there's all the options. JPEG, PNG, TIFF, etc., etc.
So most formats seem to be available.
Yeah, exactly.
Oh, okay. Thanks.
I like to personally store as SVG, which is a vectorial format, because with PNG, this is now so-called rasterized image, but with SVG, you still have a vector, which what basically it means is that if I would zoom in this, see, the fonts. All right, so continue. So basically now what we need to, what we're going to do with the next part of the course is that second. So now we're going to look at the loops. So the idea of a loop, if you're familiar with other programming languages, it's kind of the same, but of course MATLAB has its own way of defining a loop. But if you never wrote a program ever, the concept of doing a loop in programming is that you might need to repeat the same, the same part of code many times. Specifically here, we did our plot underscore patient 1.m was basically only looking for this first CSV file, but as you remember, we have actually 12 of them. So it's very inefficient to write manually 12 different scripts, and where the only thing that changes is the name of enable us to recycle the same piece of code, but with different inputs, and of course also different outputs, because we maybe want to have a, one image per each of the file. So yeah, basically, I'm not going to read this, but this is exactly what I said. So here also this, we don't need to type it, but you can understand that this is similarly to what I was just saying, that you might define a variable word called lead. So this is the value storing word, and you can manually display the first letter, the second letter, the third letter. This is not, this is a bad approach, because we are, how can I say, the same bit. Of course, there's that, for example, in this example that they write here, we might have a word that is a bit shorter. So now it's only of a length of 3. And now with this manual approach, we are trying to access the location 4 of this vector, of this array. And of course, there's nothing there. So it will throw an error that we are out of bounds, because the value 4 is out of bound 3. So then one way of doing this is to basically write a loop. So now here, the notation with MATLAB is to open the loop block with a 4 and close it with the end. So remember, yesterday we already saw this end operator, which was kind of in the context yesterday was kind of the last element of an array of a matrix or a matrix. Here instead, the end has a different meaning, which is kind of saying us it's so word equal lead. I put or they recommend us to put this semicolon so that we don't see the output, and then we do 4 letter equals 1 to 4. So this will be the indexes from 1 to 4, the integers from 1, 2, 3, and 4. Then now MATLAB is still waiting. You see at the bottom here it says continue entering statement, and the statement will be disp word of the index letter, and then end to finish the block. And now we see the output that we also see in the teaching material. So basically this is the generic kind of notation for the, so we have a 4 and then this variable index that will vary between kind of, the set of indexes that you have, and in between the block, between the 4 and the end, you have a block of code that is, going to do things. So now this would be, I'm not maybe going to type this because it's a very similar case of the case that we just typed, but you understand that, of course, because the length of this word is shorter than the previous one, then instead of having a 4 here, the loop has to end at 3. If we would still have the 4, it would complain that we would go, out of bounds. So it starts to be, of course, how can I say, inconvenient if every time we need to manually change this ending, this last index that we need to explore. So a way of doing this is to use the function length. So now, because as I mentioned earlier, I don't like honestly to use the command line directly, interactively, I'm going to make this into a script. I'm going to call it demo underscore loops.m. And so now it starts the editor. It then here, paste it. And you can do the same. So I recommend that you do the same. So now I made a script that just does this demo. Now the word is aluminum, and the length this time is, how can I say, it's computed automatically, so that we don't need to, manually check or manually write down the length of this word. So now if we type the name of the script, demo loops, yes, so now we see all the letters that are forming the word aluminum one after the other. As they say here, this is much more robust code, as it can deal identically with words of arbitrary length. Here there's another loop that repeatedly updates the variable length. So, well, kind of this is the same thing, but kind of what changed here is the code inside the block 4. So earlier we were doing a disp, we were displaying this letter, but now instead we are basically kind of incrementing of one this variable length, so that at every loop it increases of one element. And now this way of writing it like this, it's basically going through each element of this line vector, something that might be a bit confusing, that it has to be like a row vector. If this would be a column vector, it wouldn't work. This is a bit, how can I say, maybe not intuitive, but honestly, I think it's confusing to write a 4 in the for loop like this. I'd rather have always an index here. So from 1 to len of whatever is the element, and then later process here, here there's some brain work from our side that we have to start counting how many letters are this in this loop. All right, let's check if there's any question in HackMD. Maybe if there's time, I will cover this at the end, because we did this yesterday at the beginning, but maybe if there's time, I can recommend at the end about the differences of the command window and the editor, and also other windows that are in MATLAB, if that's okay. But basically, nobody's blocked. So we can continue now with actually with the feature of the editor, which is the debugger. Now this starts to be a little bit more advanced, but I'm happy kind of that they decided to include this in the teaching material already at this very kind of beginner stage, because what it's basically telling us is that when we run a script, what MATLAB does is kind of going through each line and running the statement of each of the line sequentially from the first to the end. So sometimes we might have a very long set of line, and we just want to explore, okay, what was happening before this for loop started? What was the state? Which variables were there in memory? What were their values? So it's like that we could set some breakpoints in our execution, so then we can explore, all right, we reach line 500. What was happening before? What was the state? What happens next? So this is exactly what it says here in this box. There's a nice GIF here, animated figure that I'm going to zoom a bit. So this is exactly what I was mentioning. So within the editor, you can double click on a line and set like a traffic light into red, which means that when you start running the script, MATLAB will stop at the red and then wait for your input. And here specifically in this, so here the animated GIF started. So they set the semaphore and then they press run in the editor, and then the code starts and stops there. And then you can go step by step, overlay the mouse to see the variable, and then continue to go step by step and check, here, because it's a for loop, it's, this green arrow is looping until the loop is over and basically it's exited. So you can try to do the same. I'm gonna now set the breakpoint, one click, and then we have this run button. So now you see this is the same as the animated figure. Stop there. I can check if with my mouse I can put it on top of the variables and check, what are the variables, and then I can go step by step. And here, actually, when I make the window a little bit bigger. When I move step by step, I also see things happening in the command, because now we are displaying the content. So now it's going to display the L, so the second letter. Now we are at the third letter, so I can also see what is the value of letter. It's value number 3, and basically continue step by step or continue till the end and finish. So this is a very useful feature that maybe at the very beginning you don't necessarily need it all the time, but then when you start having errors, it becomes really useful. And then when you're done with the debugging, you click again on the red spot, and the code and the editor is back to normal. All right, so now we could have a moment of a 10 minutes exercise. And what you can try to code yourself is what it says here. So we know that MATLAB computes these exponentials with this exponential operator. So 5 at the third will be 125. But exponential, of course, are, the multiplication of a number b as many times as we need. So basically, what the exercise is asking you here, how could you write the equivalent of this exponential using a for loop, considering that b is 4 and x is 5. So basically you should write a script using for that can compute 4 at the 5. So I'm not gonna click on the solution yet. I'm gonna first let you a minute that you can start working on your solution. Also, if you like challenges, don't click on the solution yet. And then I'm gonna start implementing it with you. In the meantime, I can check ACMT if there's any. All right, so I'm gonna start implementing my exercise with exponential using 4. So now notice that this is also something that I mentioned yesterday. I use this double percentage mark to say it's another way of writing a comment to say that here starts a section, and I will show you why it's useful. And then it's always good to write down what we need to do. We want to compute b at the x with b equals to 4 and x equals to 5. So for, let's say the index could be n that goes from 1 to x, and then b set to 4. So the output, the beginning is set to 1. This is my solution, so the solution of the exercise might be different. Output equals b times output. And then at the end, I can do this output. I save it. So I wrote it as a section with the 2 percentages so that I can actually right click on this section. And then one of the options is evaluate current section. So instead of executing the whole MATLAB script, I can just execute this section. And let's run it. Let's see if there's a bug. Yeah, there is a bug. I didn't define x. I run it again. I save. And I get one. Let's see if that is correct. All right. So yeah, it's the name of the output was a little bit different, but I implemented it in the same way that they had in the solution. I'm curious to know if you were able to do this exercise yourself. So if you want to use the zoom buttons and click yes, if you manage to do it without checking the solution, or no. I mean, it's I understand that it's even the coding, so it's perfectly fine to check the solution. So far I see nobody clicking on yes. Maybe we are still working on the exercise. All right, there's a couple of people who managed to do it and to click yes. So, but basically, yeah, so these are of course examples that kind of leave the time that they take, but it's good to kind of understand the very basics of this way of doing for. I wouldn't maybe do this exercise. You can do it later if you want to spend some time, but kind of the same. This is similar to what we saw earlier, with the difference that earlier this index letter was showing kind of each of the single letter of the word aluminium, but here each time we show a little bit more. So basically what changes compared to the previous one, that we always show the string from 1 to the letter to the kind of loop number where we are. So from 1 to 2, from 1 to 3, from 1 to 4, from 1 to 5, etc. So if we check the solution, the difference will be here that each time in the previous piece of code above, we only had letter, but now we have from 1 to letter, kind of spanning all the integers, indexes. And now there's another interesting thing. So yesterday we basically looked at the fact that we can have this, this column operator. Let me go back to the command window. Here it is. So, that yesterday we saw that we can do these jumps, that if we don't specify any number between the first and the last, the jump will be of 1. So now these are all the jumps of the integers from 1 to 11. But if we specify the kind of step, we can jump, in case 3 times 3 by 3. So 1, then 1 plus 3, then 4 plus 3, then 7 plus 3. But one thing, sometimes we want to do the loops in the reverse order, or we want to have this in the reverse order. So basically what it says here, you can also do jumps in the negative, with negative jumps. So in this case, I would do from 11, we jump back with jumps of -3, and we go down to the 1. So 11 minus 3 is 8, minus 3 is 5, minus 3 is 2, and then we stop because we can't go to the next one, which will be -1. So yeah, this other exercise that we don't need to go through, in my opinion. The idea is this, that instead of doing a 4 that would go from 1 to 11, it would be a 4 with the n that goes from 11 to 1 with jumps of -1, and then something. All right, but now to something a little bit more interesting, that now we have a problem here in this course, and our problem is to basically analyzing this patient data from multiple files. So that because we have 12 files, and we did kind of our statistics, our basic plots with one file, but it would be tedious to repeat it, 11 more times. So by combining what we have learned about the 4 and the loops, we can actually basically set a loop in our code so that we can automatically load all of the 12 files and repeat the same piece of code. I quickly check the markdown if there's any question, but there's no other questions, so we can continue. And so yeah, basically the first thing that we need to do is kind of get, the list of the files. It's kind of the equivalent of asking MATLAB, give me all these files. So in some case, you know yourself the structure of the file name, and here specifically the structure is that they are called inflammation-something.csv. So this star, you might have seen it in other languages and even in other operating systems, is called what's a wildcard element. So basically anything can be here. So if you can try this yourself, if you type files equal dir, which is like list the content of, and the content is a string and it's data, which is the subfolder that we have, /inflammation-star.csv. All right, I press now enter. Now you can try the same. Hopefully you also have a subfolder named data, but if you gave it a different name, then you would need to specify, a different name. Right, so in my case, I have data, and inside data I have these 12 CSV files, and by doing this, I now create a new variable called files. Now what is interesting here is there's something new that this variable is not an array or a matrix like we have been seeing so far. Now we have a so-called struct. So this notation comes from other languages, but in practice what it means that it is still an array of 12 elements, but each element is a collection of elements. So files of one, kind of the first element of this array, has this data stored inside. It has a name, it has a folder, it has a date of the file, etc., etc. And then files of two has some different fields. So the first one had the name inflammation-01. Instead, the second one had the name inflammation-02. So structs, if you're not familiar with structs in other programming language, you can access this kind of subfields of the struct by typing the keyword or the key value. So in this case, files of one dot name, it would take us to the first element of the files vector of structs and output this string. Here, one dot folder, it will tell us the folder. So you can understand that combining the folder and the name, and as we saw yesterday, we create arrays or vectors by having the square brackets. So now if I press enter, now I have a single string that is the folder and the name of the first file, kind of basically the full path of the first file. All right, so well, this is what I just explained here. All right, so now our task is that we want to loop through these files and and do something about it. So now they are recommending us to make a new script, which will be called plot all.m. So you can do the same, edit plot underscore all.m and press enter, and the editor will ask, do you want to create it? Yes, please. And here we type a little help about the script: developing code to automate inflammation analysis. And then here we have this dir command where it's the data subfolder. The file names are inflammation-star.csv, semicolon, because we don't need to look at the content. And then we do a for I, just an index that goes from 1 to the length of this array of files. And here we want to store into the variable file name the name of the specific file where we are right now, and then a disp of this variable that we have created, and end. So I save, I go back to the command window and I type plot all. So now we should see this for loop is going to display all the file names from 1 to 12 basically, and exactly that's what it did. And we get the same here. So now the next task would be to use, because this is the file name of the input, but of course we also want to create how can I, if we have the file name for each of the input, we also need to have a different file name for each of the output. Otherwise, it's otherwise it will be where we would just be overwriting the same piece of file. So here specifically, they decided to do it with the replace command. I would have not done it like this, but that's okay. So the replace is a basically way that if you have a string let's say like the input file, you can kind of, how can I say, replace a sub part of the string with something different. So here, for example, there's a way that shows how replace works, so that the string big shark, it will search for the part big, which is here at the beginning, and replaces with terror string with the terror shark. Yeah, I'm more familiar with this string replace function, which is compatible. I guess this is also in Matlab. Rep. Yeah. So I've never mentioned about Octave. Maybe I can talk about what is Octave and why here they also mention Octave. But for now, let's not get blocked because we want to be in time for the break. And so basically, have a look at kind of, get a little bit more. Or maybe actually, maybe if we start the break now and the break a little bit, so that because maybe it's good to go through this bit of code with a little bit more time. So now it's 13:48. If we can come back at 13:58, we can have a 10 minutes break, and so that we can actually check how can we go through all the files and generate a different output file for each of our input files. So let's do like this. So break until 13:58. I will check the HackMD a bit, but then I can comment later. Thanks. And of course, as I wrote here, if you already wrote down your presence earlier, it's okay. You don't need to write anymore. But if you join later, so you can send me a direct message in the chat with your name so that I can mark you down for the presence of today's session. Okay, so there's still a few seconds before 13:58. Yeah, I'm sorry if I was going a bit too fast in the coding. I understand that it's a bit, you know, difficult to see what is the average speed, but it's an important point. I will try to basically allow more time so that you can code the same examples that we are coding together. And then there were a couple of comments, questions in HackMD. So if you see that your files is empty, then what basically means is that that you might be in the wrong location, or that the data subfolder is not visible. So this, it depends where you store the files, and the person there wrote it that manages. And then this type of warning, just in case, sometimes I've seen in the past this type of thing. If I would type plotall.m, which folders am I in? No, okay, then it's not that error. Then we can check at the end the type of error, why you got that error. Okay, but so basically our task for this exercise and for basically understanding how to use these for loops in practice with a real problem, just to remind you that we have multiple input files, so multiple CSV files, and we want to kind of cycle through each of them. And now what this command here is doing, or this script here, because this is a bit of the script that we are working on, is that it's cycling through all the files, getting the file name, but then we also need to create the output name, so the name for where we want to store our file. And specifically, if the input file has an extension of CSV, one way of doing this would be to change the bit of the string that is .csv into something .png. So just to repeat clearly step by step, this script first gets the list of files like we showed in the previous, before the break. Then it would go through each file, so from 1 till the length of files, because here there's all the files, and then get a variable, a string called file underscore name, which is the name of the ith, so the I number of files from the files vector, and then generate a string for the image, meaning for the results, for the output. So then specifically, if file name here is the input and it ends in .csv, we just want to keep the same name, but replace the ending, the .csv, with .png, because we decided to use PNGs as an output. And then here there's a new Matlab function, which is called full file. So full file gives basically a valid path for, for a file, meaning that, this is what I was saying earlier. If you check the files variable, now I'm checking it interactively in the Matlab prompt. And for example, files, the first element of files, so the first file. So the actual field name doesn't contain the folder where the file is stored, because the folder is actually data. So this full file, name of the folder and name of the file, will actually generate kind of a valid path. Path in computer science in general means that, that you have all the folders and subfolders needed plus the file name, so that kind of, you can write or you can read from the exact location. So now we continue with our plotall.m. Now I'm going to try to go a little bit slower, but basically, we need to have all this into the same file. So we were doing fine with the beginning, but now it's a little bit different. So we first need to generate the string for the output name. And here specifically is image name equal replace. Use that. Notice that I started to write a rep, then I press the tab key kind of auto completes. So I start writing rep, then I press tab, and here I have many Matlab functions that start with rep, and then with the keys up and key down, I want to use replace. This is useful because sometimes you don't remember by heart the exact name function of the name. I mean, name of the function. Sorry, and so it's quite convenient. So then here we want to take the string, the variable file name, and from there we want to replace the bit that is .csv and with something that will be .png. All right. And then let me make the editor window a little bit bigger. Right. So, and then I think it's a little bit smaller. Okay, so now we have kind of the input and the output, but they are still not valid files yet. So let's also generate path to valid data file and output file. And so we have the input file. I actually don't like what they are doing here because they are overwriting the file name string. It's okay, it's not an issue, but I find it more readable if this would be something different, so that I know that this is just the name and this could be file underscore path, for example. Actually, maybe I'm gonna do it my way because it's a little bit clearer that, you know, in practice it doesn't matter, of course, I understand, but you know, coding is the first, how can I say, the first reader of a code, it's you. And if it starts to be not clear for you, then, you know, even though it's clear for the machine, it's not a good purpose. So here I used my own way of coding this bit, and then this would be results and then image name. All right, so now it's clear that what we want to use, what we want to display at the end is something file path, which is a combination of the folder and the file name, and image path, which is a combination of the output folder and the image name variable. So now I can do disp file path, I called it, and disp image path. So maybe so that I can go a little bit slower for everyone, I go again through the whole thing. So what we did here is that, by the way, just to check everything's fine, is my connection breaking? We can actually do, let me reset the votes on the Zoom, that we can do kind of like we do in the real workshops, that if you were able to basically write this code on your plot all.m file, you can click yes and put the green sticker. If you need more time, if you are still, you know, not understanding, you can click no. So this is what we normally do in the live workshops. There we actually have posted stickers that people are asked to put a green sticker on their laptop if they are, you know, if they reached the same place, or a red sticker if they need more time, or if they. So now I see at least 2 green stickers, 2 yes buttons pressed, and I assume that all the others would have a red sticker with a no. All right, but it's good to go through everything again. So our goal is to automatically go through each of these 12 CSV files that they contain different data, and then kind of loop through each file, and the final goal would be to open the file, load it, plot those averages or maximum or minimum images, and then store the image so that then we can, include it in our paper or review or give it to our colleagues to check. So the first step would be to make sure that we have the right input file and the right output file. So here we are at this stage. And so when we define the variable file name, it gets the specific name of the file in the location I, with I that goes from 1 to the length of all the files, 12. And then for the output, for the plot that we're going to do, because the plot doesn't end in CSV and ends in PNG, so we replace, basically the file name for the output will be .png. Will be the same file name for the input, but with .png. And there's an extra bit that we need to do, that because the locations of the input and the output, it's always recommended that they are in different folders. So for the input file, we know that they live in the data subfolder, while the output files will go to the results subfolder. All right, so now if I press, first I save. If you are done, if you are at the same stage, you can click the yes button in the Zoom. You find those buttons if you click on participants. And then there you see the green yes button or the red button if you need more time. So far I'm seeing 5 yes buttons. So 5 people at least are at the same stage where I am. So now I saved, and I can press this play button here, the run, that basically runs the whole script. Or instead of pressing the play button, you can also type the name of the script here, plot all. And now, so we should see a display of the input file and output file, kind of looping through all the 12 files. And now this looks really good. So now we have, you see, these are full path, not just the file names. So we have data. So this would be the first loop. Now this is the second loop. And we have the input and the output, etc. So far, so good. I see at least 8 green buttons. Maybe I can check. I can show again the editor if you wanna. Maybe I can comment again that I didn't like how they did it, that they basically replace the content of the file name with this path. So with data / file name. It can be confusing when you I understand, of course, that for the machine it's not a big deal, but it's nicer to be clear. So I gave it a different name, file path and image path. I have, of course, to remember later that I might need to use this new variable. So it's fine if you want to copy paste, but it's good to be aware of these things, that the code should be readable for you especially, and then also for the machine. All right.
Enrico, can I ask a question?
Yeah, sure.
I don't have the folder called results created.
Okay.
And yet the script doesn't report any problems.
Because basically this is a good remark, because right now we're just creating strings. We're not trying to actually, for example, write. So here are the strings that we have created. We're not really now trying to access this place in the disk. So even though, I could have written anything here, the MATLAB right now is not trying to write something there. But so if you don't have the results folder, you can check this with ls. And I have it here. You can type from the MATLAB prompt mkdir. So kind of make a directory and then results. I'm going to type it anyway. And here I should get the kind of an error, kind of like, MATLAB is going to say you already have this. Yes, warning, directory already exists. So I didn't need to, we already have it. So everyone, there's more people with a green button. There's one person who has a red. So hopefully you reach the same stage where I am. But maybe let's continue a bit. Even though somebody, I need to mute my phone 1 second. Sorry about that. Okay, so now we are at a good stage that we kind of have the input and the output files, or at least the strings for loading the input and loading the output. Now it's time to kind of, go adding more code to our script so that we can actually do something with this script, so that we can actually create these figures. So kind of the next stage is kind of combining what we did earlier with this script here. Now I'm going to click here so that I'm going to show the previous script. So this was plot patient 1. You should have it as well. And this was specifically done for inflammation-01.csv. So now kind of this part, this bit of code needs to be moved in our plot all, with the difference that here the load or read matrix will have our automatically generated input file name, and the print bit will have our automatically generated output file name, so that we have it, we do it for multiple times. So now it's basically what it says here in this other section of the code, but once again to kind of be I'm going to try to be a little bit slower so that we all can code it together. So right now we don't have the disp anymore. We don't need it. The only difference is that we have file underscore name and image underscore name, that I decided to change it for clarity. So now first we need to, sorry, 1 second. So now we want to load patient data. Because of my version, I didn't have, and also notice somebody else. This read matrix is a very new Matlab function. For our purpose, it's enough to use the load function, and then file path. This is how I called it. It's nice that with the editor, you see when I double click on a variable name, it's kind of highlighted in other places in the code. So basically now we have loaded the figure. I'm going to actually load the data. So I'm adding an extra comment so that it's clear what we're doing. Now we can load the data. And then now we create the figures without displaying them. Okay, so we do this figure visible off, like we commented earlier, so that we don't really need to see how many 12 figures coming on and off the screen with the data from the 12 files. But so for this reason, we can switch kind of the visibility of the figures. So we set it to off. And then let me scroll down a bit on the teaching material. So now we can do our, I can see here, all right, I did it a little bit different. Okay, I comment something before typing. So if you remember in the previous file, we had subplot, 1, 3, and then the location of the subplot. Because there are 3 subplots and they were all in a row here. And here they decided to do something a little bit different. So they decided to define subplot 2 times 2. So the subplot will actually have 2 rows and 2 columns. But still the kind of, so this would allow 4 subplots, but they still go from 1 to 2 and 3 and end there. So basically, I scroll a bit down here, you see this is how the image will look like. The previous image, they were all in a row. Here instead, there would be a 4th location that is not used right now, which is fine. I mean, this is kind of things that you can play with when you are preparing these types of plots for your paper. So maybe let's do it like it's down here so that it's less confusing. I'm adding more comments to make it more clear. We need to have 2 times 2 subplots and do the plots. So we start with the first subplot 2 times 2, location 1, and here we want to have the mean. And I like to do it like this, that I already type both brackets, and then I go one back. Some editors like Visual Studio Code, they do it for you, but the Matlab editor doesn't. So it's not nice that there's just one open, but you see the Matlab editor actually helps you to find where are the brackets. So then there's a mean, and then there's patient data along the first dimension, and then title, average, Y label, information, X label, day. All right. Then maybe add a comment here. And this is first we plot the mean. Then we plot the maximum. So here we select a new location in our subplot, the location 2, and the plot will be of the maximum of patient data. Maximum wants the dimension as a third input parameter, and the second should stay empty. All right, then we have title. In this case, it's the max. And the labels are actually the same, so I'm going to be a bit lazy and copy paste them from the previous block. And finally, we plot the minimum. So here again, we have the same subplot 2 times 2, but we are in the third location of the subplot. And now we want to plot the minimum, patient data, empty first dimension. And now the title is min, and the Y label and X label are still the same, so I'm gonna copy paste them. All right, and now I'm gonna add an extra comment, and now we store the image to file as PNG. So now we can do the print. In my way of naming things, I call it image path. It's nice that just function name and weight. You also get, kind of the edit tries to have, but I can click somewhere else because I don't need to see those things. And then the PNG, and then close because we don't need this. Right. So basically, we did everything that is in this example. Of course, you are allowed to copy paste if you prefer. Let's check how everyone is doing. I'm gonna then, and now again you can click the yes button, the green sticker, if you basically manage to incorporate the plotting code inside this for block. So I added a little extra comments, and of course I'm happy to share my version rather than than the version that you have on the website. So that you can get exactly the same things that I typed here. But basically, first we get all the files here where my mouse is pointing. Then we loop through all the files, prepare the full path for the input, the full path for the output, and then we actually load the data based on the input, prepare our figure with the mean, with the max, and with the min, and then store it to disk. Somebody was raising their hand, so if you want to talk.
Another question. Can you just explain the close command at the end?
Yeah, this is, you have seen me sometimes typing it in the command window. Sometimes I type close all. So of course, don't trust my word. You can always ask Matlab, tell me more. Close basically closes the window. If it's a code, which in our case would be, for example, if the figure would have a number, figure 1, figure 2, if you want the more that it opens. So the idea being, how can I explain it? So this is clearer maybe if we wouldn't have this video. If we would actually have that each time we could create a figure, we wouldn't have 12 figures in our screen, which, okay, maybe 12 figures are not a big deal, but imagine if we would need to cycle through 100 files. It's like, because we are done with the figure where we were right now, it's good to close it so that we know that the next figure will be, how can I say, we will start. I can this, find in the last lecture, last that we covered a little bit more thing on the last lecture. So, I mean, for now, I can just say that it's good to close what you open and where you started. But in practice, the reason is that, we wouldn't like to end up with too many figures, kind of, even though they are not visible to you, but they are in memory. Okay, 12 figures is not going to kill your RAM, but if you imagine that you would have to do this loop for 1,000 times, 1 million times, you would have in memory 1 million figures that you don't really need to. Okay, so
Sorry, I had a question too. I missed one point in the very beginning where you make the file names. Can you scroll a little bit higher?
sure, let me go back to the editor.
Yeah. So in this line 5, there is 6. There is this file name is equal to I. That part I understand.
Yeah.
So it takes the ith element.
Exactly. So yeah, so
What does
we
that
didn't really
do?
go into the detail of a struct. Yeah, I can comment. So the idea is that so far we've been all the kind of variables that we've been checking that were arrays or messages. So when I type whose workspace, so for example, the variable a, which is a vector, and they are double, so that they're numbers. But this variable files, here it is, it has a strange class. It's not a double, it's not a char, it is a struct. So the idea of a struct is that it's a kind of a container of different variables. So here it's like saying that we have a big container called files, and it has 12 elements, and each of them is another container of multiple data types. So the files of, we want to know more about the fifth element. So this container, let's give it, let's store it in a different variable. Let's call it container equals files. of 5. So now the variable container variables. Some of them are strings, some are numbers. This is actually like so. The idea of using struct is that the group have different types. Same container, we are putting a name, some numbers, and and then we can. So the notation would be that we container, I call it container dot name subfield of this variable, and we container dot bytes. I get the sub key of the struct, and data by typing container dot and whatever is the field name. If you don't actually know field names, you can type tab when you are like here, and it tells me that I can have bytes, date none, folder, is it a directory or name.
Okay, and where did we assign that this is a structure? Because files was just, it was the directory command. So does the directory command, does it, let's say it doesn't produce a string, it produces a structure.
Exactly.
Or
Here
is it?
I did now exactly like you said. So I did help dir, and here as it say, the dir command returns what it says here, returns the results in a structure with these fields. So yes, it's the dir command that creates a structure, but you can create this is now a small diversion. You can create the structure yourself. I can call it my struct and have a subfield that I can call name and set it to a string and pico, and then my struct with another subfield called surname and set it to Lerean. And now you see I'm creating a construct here. So this is handy. So now the variable my struct actually carries 2 subvariables, and they're both string, but maybe add something else. I don't know, my height. And now it's not going to be a string, it can be a number, and I'm 170. So
okay, that was not clear, because if you just type there dir, so to see what you have there, it doesn't show the struct, it only gives the file names.
yeah, so then we could do it like this.
So it's kind of funny that all of these are actually the structures.
Yeah, so we could do it like this, that this is output of dir, and then like equals to dir. So now I'm actually storing the output of the dir command, and now it's a struct. So here basically when we call dir without nothing, dir doesn't need to store the output, and what it does is just maybe the user just want to show what's in the folder. But then when we actually define the output, then the output is going to be a struct.
Okay.
But this also kind of, yeah, it's a, and I kind of try to make it clear sometimes.
Okay.
Same string in different context might kind of behave differently. So Matlab kind of checks what's the context. In this case, the context would be that there is no output name, or so Matlab it displays it here. But if we have an output name, then it kind of makes struct inside this output. All right, so, but basically, yeah, so if we go back to the editor, and now the plot all, sorry, oops, now my screen splitted. But basically I save the plot all command, and I minimize this. So now I'm ready to run this plot all command, and what it will produce is that it will go through all these 12 files and create these 12 figures. So I'm expecting an error because it's very common that there are typos. I didn't copy paste, so let's see if there's any error. Looks like it's not doing any error here, and the bot is saying busy because now it's going through all the files. I can check with my file manager what's happening in the results folder, and actually, yeah, it has already generated all the 12 images. Let's have a look at them. So they will not be exactly identical because each image was generated with a different input data. So this is the first image. Now I'm gonna switch to the second with my arrow keys. And yes, it's a little bit different. Now I'm gonna switch to the third. A little looks like the average is changing, but the maximum and minimum are staying quite similar. Oh, here the minimum changed a bit in the number 8 and also the maximum. So yeah, there are some properties of these files that might be similar across files, like this maximum and minimum, but clearly the average is changing at every file.
But you have also, you have differences in scaling in 6 and 10.
That's true. So this is something that, you know, because we didn't really specify. So let's see, 6, it goes from 0 to 12, 0, 20, you know, basically you can see that now I'm going through the files with the arrow up and arrow down. So 9, this goes up to 15, and instead of 10, this goes up to 12. In general, this is a very good point that now we are kind of letting MATLAB to choose the scaling, and it can be confusing if you have different plots with different scaling, because the reader will kind of be tricked that, you know, they might think that, you know, they might not look, basically they might not read the axis. So this is something that we can also keep for the last lecture, for the extra lecture, that I can show you how we could, for example, make sure that the scale is exactly the same on all figures, so that, you know, by just looking at the figures, one doesn't need to start reading the numbers, basically, and having this extra mental effort of remembering that the scale is different. Good point. So yeah, if there's no questions, let's quickly check the HackMD, if there's anything there. Yeah, this actually quickly earlier, but you can check them with the documentation of the print command. I think I had it open here actually. Yeah. So I'm gonna paste this link to the HackMD so you have it. And here if you scroll down, you find this bit, and here you see all the outputs that you can use. Okay, there's no other questions, there's no raised hands. Let's continue a bit. So basically, we were able to create these figures, and you know, you don't need to go through all the figures, but you kind of got the idea. And it's working. Hopefully it's working also for you, but the material is open. You have all the time in the world to go through it again and try it again if something wasn't clear. Maybe we move to the next lesson. This is 35 minutes. We have a little bit less than 30 minutes, but I don't want to maybe go too fast, as has already been pointed out by others. So it's okay if we don't finish it completely, but we can continue next Tuesday with our third part. But in general, so now this section is about making choices, because often, if you are familiar with programming, but even if you're not familiar with programming, you know that sometimes if you know, like an algorithm or like a structure or like a recipe, you know, if you're cooking, you need to do choices. So if there is something, then maybe you need to do something else. But if we didn't reach, you know, that limit, then maybe continue doing something. So in programming language, many programming languages have these types of statements, and usually the most common one is the so-called if statement. So here, for example, in this simple bit of code, is MATLAB is first we define a variable called num, and it's equal to 37. And then this bit of code is just checking if this variable is bigger than 100 or not. So if num would be greater than 100, then we can display greater. Otherwise, else display not greater. So once again, rather, instead of typing this interactively, we can check it actually in the with a bit of script. I'm gonna call it demo underscore choices.m. And now the editor asked me, yes, make a new script. So where are we here? Yeah, so we call it num. I'm gonna use a different number because I'm gonna use 1001. And then we do our if num bigger than 100, then display. I'm gonna be a little bit more verbose. Num is bigger than 100 or greater, be more English. Otherwise, display num is smaller than 100. In this case, actually, if you are mathematicians, we wouldn't appear also if num is smaller or equal than 100. Then we close. So like we saw for the for blocks, also these if blocks, they want to have an end. And it's nice to see with the editor that if I put my mouse, in the beginning or in the end, I can actually see where the block starts and where the block ends. And then at the end, we want to display done. So now when this script will be executed, only this part, because 1001 is bigger than 100, only this part is actually executed. And this bit of code will never be executed with these parameters. But this ending code will always be executed because it's outside the if block. So I save, and maybe, how did I call this? Demo choices. So I type demo choices, and yes, num is greater than 100. And what I noticed earlier, sorry, let me close those figures, that if I would have picked exactly 100, because 100 is not strictly greater than 100, so we wouldn't appear. This is why I wrote it that num is smaller or equal to, smaller than or equal to 100. And now when num is set to 100, I save, I go back to the command and run the script again, and num is now smaller than or equal to 100. And we can check the value of num by just typing it, and yes, in this case, I set it to 100. Basically, well, this is just saying what I was ready in that what happened before the if block will always be executed, and what happened after the conditional if block will always be executed. What happened here, middle, will be executed only if num is bigger than 100. So in this case, this will never be executed because 53 is not greater than 100. So even though here we have this command, this will not be executed. So here, now they introduce another keyword, which is else if, because the idea is that we can test these types of check. So here the first check that happens is to check if the variable num is bigger than 0. So this would be true. And so, we don't need to continue any further. We can display this message and that's it. But if this variable num would not be, let's say, would be smaller than 0, then here this is not true. Then we need to move to the next block. And the next block is checking is num exactly equal to 0. And actually, no, it's not exactly equal to 0. We need to go to the next block, which is kind of the remaining. So then num must be a negative. This is a nice example that maybe we can code it. So I call this file demo choices. I type again edit demo choices to bring up the editor, and I make a section and I call it another conditional example with else if. So num equals to 53. You can also do the same and code as well. And then if num is bigger than 0, we want to display num is positive. Oops, to close. Else if num is exactly 0, then I can display the num is 0. And then the last bit, kind of the rest of everything. If we are here, it means that num is negative. And we close. So now I can save and right click here so that Matlab will execute only this current section. So evaluate current section. And now, because 53 is bigger than 0, now in the command line I should see num is positive. Let's go back. And here the command line has written num is positive. I will now go back to the editor and use another number, for example, exactly 0. So now in the command line I will say num is 0. I save, I right click, evaluate current section, and now, yes, num is 0. There's a raised hand, so please go ahead.
Yeah, I was wondering, I might go a little bit ahead or something, but if I do a real program, then I would like to give this 53 to this subprogram, let's say outside the program, let's say in my main program. So how is this done? Can one give kind of, can one somehow deliver variables to these subprograms, or is it so that I can, for example, in my main program, I can say that num is 53, and then I drive this subprogram without specifying it?
So basically this is a good question. It's we will see it actually next time.
Okay.
It's in the next lecture. This is the when we write a function. So then I will talk about the scope of a function. So you could have, like you called it, subprogram that it might use also the num variable, and then we might want to pass the num variable from the main, or we might want to use another num variable. But we will check this basically when we go through the function. When writing any functions. All right, so well, basically this next demo that I have here, maybe I wouldn't, how can I say, code with you. You can code it later if you feel like, but here basically it's if we read it without using Matlab, we are checking this number 53, which is positive. So this is true. And if this wouldn't be, if we would be a negative number, we would end up in this part of the code. And now we are checking, is it 0? And maybe it's not 0. And then we would go to this part of the code. And this is a redundant condition because how can I say, because num, like if we would be at this stage, we would have already checked that num, if num would be bigger than 50, it would have already exited here. We would have not reached this block. So this is why they wrote here, this block will never be executed, because if we see that this is true, if num is bigger than 0, and it is here, this is the statement that gets executed, and everything else is skipped. It doesn't even test for all the other things. So basically what you need to remember is that when you do this if, else if, what is tested is always the next thing if this is false. So if this would be false, we test the next thing. But in this case, this is true, then only this bit will be executed and everything else is not even checked by Matlab. So basically it would be good to now talk about true, false, and Boolean logic. And maybe this is something that we can keep for the next part, because in that it might be worth spending a little bit extra time. And because we still have some 10 minutes, I would like to use them if there are questions for today, or if you need some clarification, or if you want to know, I can check actually the HackMD if there's anything. So if that's okay with you, I'm gonna keep the last 10 minutes for some questions, and rather than going through this true and false stuff, which is good that we resume later on next Tuesday. So maybe I'm gonna stop the recording now.